Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So angles on a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's a million. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13. And then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. The first thing that we can actually work out for this Venn diagram is this part here. So it says 12 had a cat but not a dog. So the cat but not a dog is showed with this A here. So if 12 had a cat but not a dog, and in total 22 had a cat, we're going to do 22 take away 12, which is 10. So 10 had a cat and a dog. If 16 had a dog, and 10 also had a cat, that means that 6 had a dog. Let's make sure we fill these in. And if overall there were 31 people, and there were 12 who just had a cat, 10 who had a cat and a dog, and 6 who had a dog, that leaves 3 left over. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2, and the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19, and we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include a, s, v, and u? That's got a t in it, that's got a t in it, so it's going to be this one here. So let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148 blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it'd be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared. And we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants it to 2 decimal places, so that will be 61.19. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9,000,000. And so we're just subtracting them like that. And so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the two parallel sides here. Just pick a different colour. Here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles. So that's what we've got here. So the area would be half times a, which is 28, plus b, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now keep that in my calculator, because next thing we'll do is the shaded area part. And it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah. And when you do that, you get 140.061, blah, blah, blah. It says it wants it to 2 decimal places, so it would be 140.06. So we're given a right angle triangle here, and we're asked to find length AC, which is this length here, and we're given 2 other lengths, so we're going to be using Pythagoras. Pythagoras involves us labelling the sides, A, B, and C, with C being the one opposite the right angle. And we know Pythagoras is a squared plus b squared equals c squared. Both a and b here are 4.9, so it'd be 4.9 squared plus 4.9 squared equals c squared. So we're going to add the 4.9 squareds together, and that will give us 48.020 blah blah blah. And here we're going to do a bit of solving. So we're going to square root both sides to find out what c is. So square root of 48.020 blah 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 is 6.929 blah blah blah. Rounded to 2 decimal places, this will be 6.93. When working out if 2 triangles are congruent, which means they're the same, you can either have RHS, which is a right angle hypotenuse side. You can have 3 sides that are the same. You can have 2 angles then a side, or an angle then a side then an angle, or you can have a side then an angle then a side. In this question we have a right angle. We only have 2 sides, so we can cross this one out. And if you look, that the 2 sides are next to each other then the angle, so it's ASS or SSA. So these don't really fit. But the angle is a right angle. So we've got a right angle on both of them. We have the hypotenuse. And we have a different side that are all equal. So the proof here is RHS. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So the angle of elevation is when you are looking horizontally, like here. It's the angle that you have to look up to see something, so that castle. So this is the angle of elevation here, which I'm just going to call x. And we've got a right angle triangle here where we have two lengths and we're looking for an angle, so we're going to be using trigonometry. So we're just going to label this up. So we've got the opposite here, adjacent to here. We don't need the hypotenuse at all, so get rid of that. Let's just put our SOHCAHTOA in. So we've crossed out the hypotenuse, so it won't be sine or cos, it will be tan. So it would be tan x is equal to the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan of both sides. And so the inverse tan of 49 over 98 is 26.565, etc. And it says it wants the nearest whole number, so that will be 27 degrees. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word and in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be -2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8, and those are our solutions. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one. And then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10. And that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, or for this, will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. I'm going to first of all draw the two triangles out separately. And we've got A B, C, and then A, D, E. And the first thing to notice is we have similar triangles here, and the way we know that is that we've got an F angle here, which means they're corresponding on the two parallel sides, so these two angles are the same. Got exactly the same thing on this side, we've got F angles, so these two are corresponding, and then the top angle is shared between the two triangles. And when you've got two triangles with exactly the same angles, they are going to be similar, which means one's an enlargement of the other. I'm just going to put on the length that we've got. Now we're looking for quite a complicated one. We're looking for the length CE, which is this one here. Now I can't actually label that onto my two triangles, but what I do know is that CE is equal to AE minus AC. Now we know what AE is, which is 60. So we just need to find out what AC is, this one here. And when we find out what AC is, we can just take them away to work out what the CE is. So we need two corresponding lengths that we know both of them. So we've got the 9 and 36 here. Because these two triangles are similar, we know that we can work out what the scale factor is. And to work out the scale factor, you do big divided by small. So 36 divided by 9. And we work out that that is going to be 4. So we know we're going to have a scale factor of 4. So to get from the smaller triangle to the big one, we times it by 4. But here we have the one, we need to find out what this one is. So one corresponding is this one. We're going from the big to the small. And so to work out from the big to the small, we've got to divide it by the scale factor. So divide it by 4. So 60 divided by 4 is 15. So we know what this one is. So AC is 15. And so we're going to do AE, which is 60. Take away the 15, and that will tell us what CE is, which is 45. So our answer is 45. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that will be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. To work out the area of this sector, there is actually a nice little formula that we can use. And I'm just going to show you what the formula means. So the formula is going to be what fraction of the full circle do we have. Okay, so we're going to find out the fraction of the full circle we have. And then we're going to times that by the area of the circle. So to work out the fraction of the circle we get the angle that we have in the sector, and we divide that by the total amount of angles in a circle, which is 360. Then we times that by the area of a circle, so pi r squared. Let's use that for our question. So the angle we have for this question is 57 times pi r. Now, to work out what r is, we just imagine the circle is whole. I'll do a badly drawn circle. And you can see here that this length here, this 5 centimeters, is the distance between the center of the circle and the circumference. So that is a radius. So it's going to be times 5 squared. Put that into your calculator and you'll get 12.435 blah blah blah. And it says it wants its 2 decimal places, so we round that to 12.44 centimeters squared. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different, which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. So we notice on the simultaneous equations that the coefficient of the y's and the x's are different. I always focus on the y's and make sure they're the same. So we've got to make them the same, ignoring the sign. So we've got a -2 and a +3. So to make them the same, well, 2 and 3, the lowest common multiple of 2 and 3 is 6. So we've got to make them both 6. So we're going to do 6x and -2y equals -21. And we're just going to multiply everything by 3 to make the coefficient of the y's the same. Times them all by 3. And we get 18x minus 6y, which is good, so that's what we're looking for. And that's going to equal -63. On the second equation, I'm going to write that out. 7x plus 3y equals -1/2. And this time we're going to times everything by 2. So times all the terms by 2. And we get 14x plus 6y, which is good, so that's what we wanted. and equal -1. So I'm going to write these in together. So I'm just going to copy the same equations again, but we're just going to have them next to each other so we can start working our simultaneous equation magic on them. And we're going to get our circles going downwards. Remember, simultaneous equations are all about going downwards. Make sure the signs go with the y. Now we've got to work out what sign we're using here. And the way I remember it is looking at the y's, because that's the thing we're trying to deal with, we're trying to get rid of. Looking at the signs, if the signs are the same, we subtract. If they're different, we add. So looking at the signs, there's a negative and there's a positive, so they are different, so we're going to add. So we're going to add the y's together, but we've got to do the same to all of them. So we're going to add the 18x and the 14x, we're going to add the 63 and the -1. So going downwards, and let's draw a neat little line to show that we're working out the sums. So we've got 18x plus 14x, which is 32x. We've got 6y minus 6y plus 6y. The two pluses make a plus, so it's minus 6y plus 6y, which is nothing, which is good. That's what we're trying to do, is get rid of the y's. And then we've got minus 63 plus minus, which just makes a minus. So it's minus 63 minus 1, which would be minus 64. There we go, just quickly solve. That's going to be nice and easy because we're just going to divide both sides by 32 to get x on its own. So we've got x equals minus 64 divided by 32, which would be minus 2. So x is minus 2, but we can't stop there because we need to find out what y is. So what we're going to do is go to the original equation, and we're just going to substitute in the x for minus 2. So we're going to do 6 times minus 2, minus 2y equals minus 21. So 6 times minus 2 is just going to be minus 12. Add 12 both sides, and that will give us minus 2y is equal to minus 9. Then we've got a minus 2y as the coefficient of the y, so we need to divide both sides by minus 2y. The two minuses will get rid of each other, so it's 9 divided by 2, which is going to be 4.5. And we can check this by putting the x and the y into the other equation and see whether we get the answer of minus 0.5. This question is the same as questions you get where you've got y equals 8x squared and you've asked to find what y is when x equals 3. The questions are exactly the same, but instead of y we write f of x, and this is saying that the function is 8x squared and we want to feed in the 3 into the function. So it's going to be 8 times 3 squared, and 3 squared is 9, and 8 times 9 is 72, so the answer would be 72. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100, so that would be 65%. So here we're going to solve a quadratic using a calculator, using the quadratic formula. And the reason we know that is it asks us to do it to 2 decimal places, so chances are it's not going to factorise. So we're going to find out what a, b and c are. And a is the number before the x squared, the coefficient of the x squared, which would be 5. B is the coefficient of the x, which would be minus 6. And then c is the number left over at the end. So we're going to write the quadratic formula, but with our values in it. So we have minus b. Now I always put the values I substitute in brackets, and the reason is that if they're negative, you can make mistakes, especially here. When it's b squared, if you don't put it into brackets, it won't give you the right answer because it will square the 6 and then put a minus before it. Minus 4 times A times C. And if you always put them in brackets, you don't even have to think about it. It'll always be right. And then over 2 times A. Okay, we're going to put that into our calculator with a plus there first. And it gives us 2.320 blah blah blah, and we're going to do the same thing again, but we're going to use our calculator to go back to the plus there, and we're going to change it to a minus, and then we're going to press equals, and that gives us minus 1.120 blah blah blah. So it's 2 decimal places, it's going to be 2.32 and minus 1.12. So we know these cuboids are similar, so they're going to have a scale factor, and we can work out the linear scale factor, and to do that we've got to work out what we times 17 by to get to 161.5. So we'll do 161.5 and divide it by the smaller one, which is 17, and that's 9.5. So the linear scale factor is 9.5. Now this is all about volumes, and we're told that the smaller volume is 85, and we've got to work out what the larger volume is. So to work out what a volume scale factor is, what we do is we cube the linear scale factor, because in a volume there's 3 dimensions, so we're going to times it by the linear scale factor 3 times. So 9.5 cubed, so the volume scale factor is going to be 857.375. So we're going to times anything, or any volume, by that, and it will give us the larger volume. So we've got the 85, and we're going to times it by 857.375, and we get 72876.875. So notice it's a lot larger. Yes, the linear scale factor has gone up by just under 10, but you look at how big that volume is, and that's generally what happens. So the first thing I'm going to do is I'm going to look at the coefficient of the x squared, look at the number on its own at the end, and I'm just going to multiply them together. So 11 times 6, which is 66. And 66 is going to be quite a useful number, because what we're looking for is 2 numbers that times together to make 66. And we're looking for the same 2 numbers that add together to make the coefficient of the x, which would be minus 25. Now, something we know about these numbers straight away is they must both be negative, because they sum together to make a negative, but when they're multiplied they make a positive. The only way that can happen is if they're both negative. And so what I'm going to do is I'm just going to look at 66, and I'm just going to write all the factors of 66, but we know both of them must be negative. So it'd be minus 3 and minus 22, and then minus 6 and minus 11, and then the rest will just be the other way around. So when I add these together, I'm going to look to see which one adds together to make minus 25, which is actually going to be this one here. So our 2 numbers are going to be minus 3 and minus 22 that we're going to be using. Now it seems like a lot of effort so far, but there is wisdom to this, because what I'm going to do now is I'm just going to rewrite this, but instead of minus 25x, I'm going to split it up. So I'm going to split it up into minus 3x, minus 22x. There's the minus 3 and the minus 22 that we've just found, and then plus 6. Next step is I'm going to factorize this linearly. So I'm going to do this one, and I'm going to do this one as 2 linear factorizations. So I'm just looking at the purple box, and well, there's no numbers I can divide out of both of them, but there is an x. So this will be x brackets 11x minus 3. Now we've got a bit of a weird situation here, because you'd think that it would be 2 that we divide out of both of them, but it's actually going to be a minus 2 because there's a minus there. So it's going to be minus 2, and then we've got 11x plus 3. Now notice what we have here. We have a repeating bracket, both of these are 11x minus 3. And I've made a mistake there. Let's just quickly correct that. That should be minus 3. And I was just about to say, if they're not matching, it means you've done it wrong. The mistake I made there was minus 2 times positive 3 would not give us the plus 6 there. It would give us minus 6. So that needs to be a minus 3. So there's a repeating bracket there, and that is actually one of our answers. And the bit that's left over is an x and a minus 2. And we actually put those together to make a second bracket. And so our answer is x minus 2, 11x minus 3. Or the other way around, you could have 11x minus 3 brackets x minus 2. When solving simultaneous equations graphically, the solutions are just where the two graphs meet. So we've got y equals x plus 4 drawn, and we've got y equals x squared minus 2 drawn. So the solutions will be here and here. So the coordinates will be x equals minus 2 when y equals 2, and x equals 3 when y equals 7. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. We've got to first of all work out what the area scale factor is between these two parallelograms, and since they're similar, we know that there is going to be a scale factor. So we need to find out what I times the 120 by to get to 3630. So I'm going to do 3630 divided by 120, and that gives us 30.25. So we times the area by 30.25, but the area scale factor is equal to the linear scale factor squared. Okay, so you square the linear scale factor to find the area scale factor. So if the area scale factor is 30.25, to find the linear scale factor, we square root it to find the linear scale factor. So we're going to square root 30.25, and we get 5.5. So the linear scale factor is going to be 5.5. So we're going to times the 20 by 5.5, and when we do that, we get 110. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice, then water will be 6 over 27, and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this, or this, or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. To answer this question, we're going to do something a bit weird on the calculator. And this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution. And you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309, equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. I'm going to start off this question by factorising the denominator of the first fraction. And so we've got 1 over... I'm going to factorise it. Now, if you want to see how to factorise it, you can see other videos we've got. I'm kind of assuming you know how to factorise this if you're watching this video. And just keep the second fraction the same. Now, you can't add fractions unless you have the same denominator. So if you look at the first denominator, the only difference between the first and the second is that 8x plus 3. So I'm going to times top and bottom of the second fraction by 8x plus 3. Now it helps us to remember that, technically that bottom expression, the x plus 2, is in brackets. So I'm going to just copy down the same first fraction, because we're not really doing anything with that. And what I'm going to do is just times top and bottom by the 8x plus 3. 1 times 8x plus 3 is just 8x plus 3. And that should do it neatly. And we've got the 8x plus 3 times the bottom, which will just give us the same denominator. So now the denominators are the same, we can just add the numerators. So it's just going to be 1 plus 8x plus 3, or in other words, it's going to be 8x plus 4. So it's 8x plus 4. And the bottom one is going to be 8x plus 3 and x plus 2. When we have a times 2 inside the function, so it's 2x, it actually does the inverse to the x coordinates. So it actually divides all the x coordinates by 2. So if we see this coordinate here, which is what, 2, 3, that will now become 1, 3 on our graph. Okay, and this one here is at minus 2, 3, that will be minus 1, 3. And similar to all of these points, so we're just dividing each of the coordinates by 2. We're halving each of the coordinates. And so what you'll end up with, and we're just going to try and roughly sketch this out. It's not going to be perfect, but there's a graph that looks something like this. It will still cross the y-axis at the same point, and then we're going down to about here, back up again, and somewhere there. I reckon I could probably do that a little bit better, maybe, I don't know. And this isn't supposed to be perfect, but the examiner can clearly see that I've halved all the x coordinates. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in, because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side, because that gets rid of the denominator. And it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I'm going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, what is it, 56,100. I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870. And we're going to take that away from both sides. So take away 1870x from both sides. And that will leave 5100x on the left hand side. And then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So a is 17. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put like notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in. It's not a problem. So we can just rewrite this function as y equals x over 10 minus 11. And we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides. And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx. the function, the kx plus 2, we're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.